All right, in this video, we're going to do kind of a simple thing. We're going to plot a point on the rectangular coordinate system. That's nice and easy, but after that, they ask us to find 3 additional points that are symmetric to the original point with regards to the x-axis, the y-axis, and the origin. So that part is a little bit harder. To do that, we have to understand the rules of finding symmetric points, and that's going to be pretty easy to remember because they're kind of like the rules for symmetry. I have the rules for symmetry set up over here, so if you want to look at those last 3 bullet points, you'll see the rules for symmetry. And they're kind of related to what we're going to do here, so if you sort of forget what we do, just kind of refer back to those 3 bullet points, and that'll give you an idea of what we have to do. Okay, so let's talk about the original point and how we plot it. The first component of the point is the x component. The second part is the y component. On the rectangular coordinate system, that means we'll move from the origin out 3 units to the right on the x-axis in the positive direction. And we'll go down in the negative direction 2 units for the y-axis, and we find the place where they intersect. And that's our original point, 3, -2. So we'll do our original point in black. Let's do the point that's symmetric to the x-axis next. So the x-axis point, we're going to do that in blue. And for the x-axis point, we're simply going to do the following. We're going to set the opposite variable to the opposite sign of what it currently is. So we're going to set the y variable to the opposite sign, and we'll keep the x variable the same. So we'll still have 3, but instead of having -2, we're going to change it to +2 now. So the x-axis point, or the point that's symmetric to the original point across the x-axis, will have coordinates 3, 2. So we'll go 3 in the positive direction, but we'll go up 2, right, on the y direction, and we end up with this point here, and that's the point 3, 2. And again, that'll be the point that's symmetric to the x-axis regarding the original point. So again, it's like a mirror image, right? You can see kind of there's this nice kind of mirror symmetry, right? If you folded the rectangular coordinate system in half across the x-axis, you would end up having the 2 points lay on top of one another. All right, let's do the next point, the y-axis symmetric point. Let's do that one in red. And for the y-axis point, you set the opposite variable to the opposite sign. So we're going to keep the y component of the original point the same, so we'll keep it as -2. But the x component, which used to be 3, will now become -3. And so that's the point that should be symmetric to the original point across the y-axis. So we'll go 3 to the left, right? In other words, in the negative x direction, and down 2 for the negative y direction. And we get this point that's located here. And again, you can see if you folded the rectangular coordinate system across the y-axis, right, you would have this sort of mirror image, or the 2 points would overlap one another. Okay, so that's our point, -3, -2, and that's the y-axis symmetric point. All right, let's talk about the origin point, or the point that's symmetric to the origin with respect to the original point. Okay, we'll do that one in green. And for your origin point, you set both of your original components, the x and y components, to the opposite signs that they were given to you. So if we had +3 for x, we'll now have -3, and for the y, instead of -2, we'll make it +2. And that point will be symmetric to the original point across the origin. So let's plot it. We'll go 3 to the left, so 1, 2, 3, and then we'll go up 2 on the y, and it ends up putting us right there. And that's the point -3, 2. And so the folding here is a little strange. We'd actually fold the coordinate system across this diagonal line, y = x. And if we folded it across that, the 2 points would lay on top of one another. So that's basically how that origin symmetry is described.